Hey, it's Mr. Luneski. We are looking at 3D figures, and we're going to look at volume and surface area, particularly of composite figures. If you remember, composite figures are when you kind of take two or more shapes and sort of put them together, or you remove a shape from another shape. So typically here we're going to be adding or subtracting pieces. Talking about volume and surface area is if you were, I always refer to wrapping something. If I wanted to cover this object in wrapping paper, how much of that object would I cover, or how much would I need to cover it? That's what surface area is. Volume is when you're filling an object, so how much would fit inside of a figure. That's volume. Surface area is an area. So it's still in units squared. Volume is going to be in units cubed, because we're fitting cubes inside of the object. So we're just going to go through and do 3 examples here where we're finding the surface area and the volume for each of the figures. Volume tends to be the easier thing to do, so I'm actually going to start with the volumes for each figure. If you take a look at the figure of what we have here, we actually have a cone, and we have a half of a sphere. So I'm going to say volume of cone, and again, because this is sitting on the sphere sitting on top of the cone, we're going to add these. So volume of the cone plus the volume of, and I'll say half sphere. And so now we're just going to kind of use our formula sheets and fill in what we know here. So the volume of a cone on your formula sheet is volume equals 1/3 pi r squared times h. And so let's just look at the cone real quick. So we have the 1/3, we have the pi. What's the radius? Well, if we look here, that dotted line goes the whole way across. So that's actually giving us diameter. So diameter is equal to 18. If you recall, diameter is equal to 2r. So to find the radius, we're going to divide that by 2. So the radius is 9, so 9 squared times, and then the height of the cone is given right here, so that's 26 centimeters. So now I basically am just going to go through and simplify that out. When I simplify the volume, punch that all into the calculator, gives you 2,204.28. That would be centimeters cubed. So now volume of a half sphere. The volume of a full sphere is volume equals 4/3 pi r cubed. So that's the volume of an entire sphere. We're not doing an entire sphere, we're doing half of that. So I'm then going to divide all of that by 2. Notice that the radius for the cone was the same radius for the sphere. So basically the only thing we're substituting in there is that 9 for the radius. So again, just kind of punch all that into the calculator, and when you simplify that out as a decimal, you get 1,526.04. And again, we're adding these two numbers together. So when I add those two numbers together, that's going to give me my total volume. Total volume ends up being 3,730.32 centimeters cubed. So that is volume. Surface area is a little bit more involved. So we want to cover this thing. So we have, again, a half sphere and a cone. But when I have surface area, you need to remember, like, you're wrapping something. So if I was wrapping this object, this part would not get covered. The base of the cone, because there's that sort of circular part on top of it, and so that part doesn't get included in the surface area. So if you look at your formula sheet, you're going to notice that there's sort of two things written there. There's SA, that's surface area, and LA, that's lateral area. A lateral area of a figure is when you're just including the sides. If you think about lateral movements, it's side to side. So you're not including the base. So we're actually going to be using lateral area of the cone here. So let's pick a different color. So I'm going to say lateral area of the cone plus, and then surface area again of the half sphere. I like to just write them out because, again, I'm visual and I kind of like to see, like, okay, here are my pieces that I'm doing. So the lateral area formula for a cone is pi r L. L, that cursive L, stands for the slant height. The slant height of a figure is this piece right here, which we don't actually know. But what we do know is if I take a sliver out of that cone and I want to solve for that slant height, I know that the height here is 26, and I knew that this radius here was 9. And so we are going to use Pythagorean theorem to solve for the slant height. So I'm actually going to do that work right here. I'll say L squared equals 9 squared plus 26 squared. And when I simplify that, you end up getting L equals 27.5. So again, just square these, add them, and then square root that. So L is about 27.5. The radius we know is 9. So pi times 9 times 27.5. So that's going to give me my lateral area for my cone. That comes out to be about 777.15. And then the surface area of the half sphere. Surface area of a sphere is 4 pi r squared. But again, we are doing half of that, so we can just divide it by 2. If you notice here, 4 divided by 2 can be simplified to just 2 pi r squared. So this is actually what we're going to use here. We could have kept it like this, but I'm just going to simplify. We still know that that radius is 9, so we're doing this number plus 2 pi 9 squared. When I simplify that out, that comes out to be about 508.68. So when I add these two numbers together, that gives me a surface area of 1,285.83 centimeters squared. All right. If you want to see the other two problems, continue on to the next video.